Hello, year 10. Today we're learning about electromagnets, but because we're at home, we can't really do any of the practical stuff for this whole unit. So the way it's going to work is we will do a lot of the theory stuff. We'll probably then go back and revise some of the earlier units because we're actually ahead of time. And then when we get back to school, we will do all of the practicals in one and sort of recap some of the theory. Hopefully we kind of remember a bit about permanent magnets and induced magnets, and I'd like you to think about some uses for being able to turn a magnetic field on or off. Now if you want to, you can pause the video. If not, we are just carrying on. Now, for today's lesson, there's a few things we need to know, and then I'm going to take you through an example, and then I'm going to get you to do some questions. Now the things you need to know: if you have got a copper wire, which is what wires are usually made of, copper wire will not be magnetic because copper is not a magnetic material. But if you pass a current through a wire, it will create a circular magnetic field. And you can see on the screen here, if I wiggle my cursor around, this guy or girl can figure out the direction that the magnetic field goes by pointing their thumb in the direction of conventional current, and their fingers curl around the wire. Now, the way that their fingers point show you the direction, okay, that the magnetic field goes around. And remember, when you draw magnetic field lines, it's not just drawing the lines that's important, it's drawing the arrows on the line that's important. Okay, that's called the right-hand screw rule. So, now, the first key word that we need to know, a solenoid. If I was to get that wire that I had in the slide before, and then I was to curl it round lots and lots of times, that circular magnetic field, okay, stops being circular and it gets a bit distorted. And then eventually, after enough turns of wire on the coil, it turns into what looks like a bar magnet. And if you draw the magnetic field for a bar magnet, you'll see they're very similar. Now, the solenoid is a coil of wire. An electromagnet is a solenoid that has an iron core in the middle. Okay. Now, the whole point of the iron core, it makes the magnetic field stronger. I talked about domains before, and I'll talk about them again when we get back to school. But it's all about the domains lining up with the magnetic field to amplify that strength. Now, here, I'm going to show you the simplest way to make an electromagnet. There it is. A piece of wire attached to a battery that's curled around a nail. And this paper clip is attracted to this nail. Okay. Now, that is a very simple electromagnet. Usually, there'll be more curls of wire, there'll be a proper soft iron core, and there will be a way to turn it on and off, and a way to change the strength by varying the resistance. But the next thing we would do would be making an electromagnet, but we can't do that until we go back to school. So for now, I'm going to show you a simulation. Here is your bar magnet. Okay, remember, the red arrow here is the arrows that we would draw on the line. So remember, the arrows point from the naughty north to the sexy south, and if I had my compass here and I moved it around, I can see, okay, the direction of the field lines. Now, this is my strength meter. It shows me the magnetic field strength. This top one here, just look at that, okay, that is the magnetic field strength. Ignore these ones for now. If you look, the closer I get to the end of the magnet, or the pole, sorry, the stronger the magnetic field strength is. The further away, the weaker it is. Okay, so you can see that closer I am, I have a stronger magnetic field, and as I go further out, it is weaker. So it is strongest at the poles. Now let's look at an electromagnet. Move this out of the way. Here I've got a battery, or a cell, attached to a coil of wire. Now there isn't an iron core in this one, and the animation won't let me put one in. So technically this is a solenoid, but let's just pretend there's an iron core in the middle. Now let's see, the strength of the magnetic field is 0 because there is no voltage going through here, but let's put the voltage up to 1. You can see the electrons moving through the wire here. This is what is creating the magnetic field. Now I'm going to put my field meter there. Notice it is 12.54. If I now increase the voltage, you can see these electrons going faster and faster and faster. Notice the strength of the field goes up as the current in the wire increases. Okay, even though I am increasing the voltage, okay, the important bit is these electrons are moving faster. Okay, the current in the wire is greater, or the rate of flow of electrons is greater. So now I've got 100 there. Now I'm going to put it back down. Now I'm going to change the number of loops. Notice, let's put it on 10. 31 is my value for the strength of the magnetic field. Now if I increase the loops, I now have 62. Okay, right, so let's leave it here. 12, 25, 38, 51. As I increase the number of turns of wire on the coil, the magnetic field strength increases. As I increase the current flowing through the wire, the magnetic field strength increases. Okay, now the last one is, if I put a softer iron core in the middle of this, the magnetic field strength will increase. Now that is a required practical that we need to do when we go back to school. So the most important bit here, which is what you should write down somewhere. Okay, these are the 3 points. To make an electromagnet stronger, you can 1. Increase the current, 2. Increase the number of turns on the coil, or 3. Use a softer iron core. Please do not say increase the coils on the wire. That's not correct. You have to say the number of turns on the coil. Now, this is the question I want you to answer. Think about a permanent magnet and what you've learnt before. Think about an electromagnet and what you've kind of learnt a bit today. I want you to compare them. That means you have to say something about one and compare it to something about the other. Okay? And even if it's obvious, you still have to state it. So for example, a permanent magnet is always on, whereas an electromagnet, you can turn it off or on. There's an example of a comparison. Could you do that, please? Then, afterwards, there are a few different questions in the folder. I'd like you to pick a bronze or a silver or a gold to do. Just one question. Okay, choose bronze, silver, or gold. If you fancy it, you can do the extension. And I'll show you the stuff in the folder here. So here it is. That's where the questions are. There's an extension if you want. There's some information, just a bit of extra information. And I will put a link to this guy. Okay, if you really didn't like my PowerPoint, this guy can talk you through electromagnets in 4 minutes, which is a lot quicker than me.